Zero latency has become the industry's singular focus. Historically, enterprise data was constrained by heavy processing requirements, but today, that speed barrier has collapsed. In the legacy workflow, a stakeholder might wait 3 weeks for a dashboard sprint to conclude. Today, they can prompt a conversational AI and receive a SQL-backed answer in under 10 seconds. Dropping a large language model directly onto raw, messy data tables triggers an immediate operational crisis. Without a governed framework, the AI has no way to distinguish between production records and internal test accounts. The model writes syntax-perfect SQL that executes in milliseconds. Because the result appears instantly and looks authoritative, non-technical users often accept the math as fact, even if the underlying query misinterprets the business logic. High-speed query generation breaks business alignment when there is no anchor for the underlying logic. Different departments inevitably arrive at conflicting conclusions using the same data. This failure state is the analytics inferno, the production of plausible but mathematically incorrect figures at enterprise scale. Semantic divergence occurs when AI guesses user intent. If marketing, finance, and product all prompt for revenue, the AI might interpret it 3 different ways. When high-speed engines execute these distinct interpretations, 50 stakeholders generate 50 conflicting charts in under a minute. This flood of official-looking, mismatched numbers leads to dashboard wars. Executive meetings stall because no one can agree on which version is correct. Non-technical leadership cannot audit the AI-generated code to resolve the discrepancy. They are forced to choose between competing visualizations without knowing which one is anchored in reality. Fast compute running unverified SQL yields instant wrong answers. To scale AI analytics safely, the architecture must change. The remedy is a decoupled architecture that separates storage, compute, and logic into distinct, manageable layers. At the base, data sits in open storage formats like Parquet or Duck Lake. This keeps the raw information accessible and portable, rather than trapped in a proprietary system. The compute layer shifts toward engines like DuckDB and MotherDuck. These tools process gigabytes in milliseconds. This avoids the BI double dip. Organizations stop paying for massive idle clusters and expensive per-seat software licenses just to display static charts. The budget redirects from software subscriptions toward variable compute costs and the specialized engineering talent required to maintain the stack. Solving for speed and cost is only the first step. Rapid compute makes governed logic more critical, as errors now propagate across the organization in seconds. Hard-coding metric logic into individual dashboards or relying on dynamic prompt instructions creates a massive vulnerability. If formulas are scattered, they will eventually contradict one another. To prevent this, the architecture requires a code-first semantic firewall, a centralized hub where business logic is defined in version-controlled code. Here, a metric is defined exactly once. Every department pulls from this single formula, ensuring identical logic across every report. Data teams then use model context protocol servers to anchor large language models to this governed logic. These servers constrain the AI, forcing it to translate natural language into queries against pre-tested metric models. The AI is physically barred from guessing database schemas or making assumptions about how tables join. The semantic layer acts as the mandatory firewall that makes high-speed AI analytics completely reliable for the enterprise. Securing the logic is only half the battle. Relying solely on conversational interfaces for day-to-day operations creates a new form of friction. Prompt fatigue is a reality for non-technical stakeholders. Most executives do not want to actively formulate and type complex questions every morning to understand their business. Effective teams deploy a hybrid of active and passive services. While AI handles ad hoc questions, lightweight visual apps provide scannable trend lines and historical context that users can digest in seconds without effort. However, in validated environments like healthcare or financial services, legacy commercial BI platforms still provide a necessary moat. These services offer deterministic row-level security and turnkey audit trails. In a regulated setting, an auditor must verify exactly who saw what data, a level of certainty that probabilistic AI cannot currently match. A mature, decoupled stack balances the speed of conversational AI with the passive reliability and strict governance of visual data products. This architectural shift marks the end of the traditional BI developer role, where the primary output was the manual fulfillment of dashboard layout requests. The context analyst and the semantic engineer occupy the center of this new workflow. These specialists manage the socio-technical context and AI system prompts that dictate how an organization interprets its metrics. Their focus remains on the integrity of the semantic models and the engineering of rich model context protocol servers, ensuring that the AI never miscalculates enterprise metrics. Reliable, error-free infrastructure often makes the engineering team's work invisible. When an AI agent delivers an accurate answer instantly, it is easy for leadership to assume the model performed the calculation autonomously, obscuring the human-built architecture beneath it. Data leaders must prove value by tracking AI accuracy, cost efficiency, and time to insight, rather than the sheer volume of dashboards delivered. Successful implementation requires a profound shift, moving away from pure technical execution and embracing a holistic product management mindset. When metrics are treated as purposeful products designed for specific stakeholder decisions, the data remains aligned with actual business outcomes. AI provides the boilerplate SQL, and the duck stack provides the speed, but defining the logic of the business remains a human responsibility. Success in the decoupled BI architecture depends on engineering the specific context required for confident decision-making.